Hi everyone. I want to talk through your first, if you like, proper lab, which is solubility curves. Okay. Now, before we go into the lab itself, let's talk a little bit about, some housekeeping stuff, right? So first things first, double check, make sure you've signed on to the GRP 102 lab site. So, in that, first day of class things to do message, check for the link to that, click there, make sure, in your courses at Canvas, you get the GRP 102 up here. Okay, then you're kind of signed up for labs. Okay, and then once you, it's always complicated. Once you've signed up for GRP 102, then, okay, follow the links to Pivot Interactive. Most of our labs obviously are going to be, all our labs are virtual, right? Okay, and they're done typically through Pivot Interactive. And I think there's one other third-party site, but that's just, there's no code to get into that one. But anyway, the code I sent you, which is class-specific, also in the things to do on the first day of class, use that to sign up for Pivot Interactive. And then you're ready to go with labs. Okay. Now, remember, hopefully you've watched my my video for this week, okay, and that's essential because it talks about solubility curves, so it gives you the information you need. So, if you haven't watched the videos for this week yet, go watch them, okay, because you'll need that information. And it's kind of a philosophy thing, right? So I always like to get the information out there in class first, and then you can go into the lab and hopefully it'll be a little bit easier for you, all right, okay, so always, every week, lecture before lab. My advice is try and get all your lecture stuff done by Wednesday, okay, and then leave the next couple of days to get the lab done by Friday, okay. I know I say on there that the deadline is for both is Friday, but stagger those, right? Make sure you do lecture first, lab second, and if you do lecture first, you can ask me questions at the office hour on Thursdays. All right. Now, I mentioned it there. Make sure you do the lab assignments by Friday. The deadline on the Canvas is what I'm going to stick to, okay? So if it's after, 11:59 on Friday, it's late, okay? And it's 10% off per day, so be careful. And yeah, 1 minute after midnight's late, okay? I'm a binary function kind of person, okay? Next thing, students always ask about the grade scheme. How am I doing on labs? Well, here's the thing. If you ever want to know how you're doing in labs, just send me a quick email. Don't do it every week. Maybe once at midterm, once closer to the end or something. And I'll send you back like a, just the line out of my Excel sheet with how your lab scores are. Okay, and I'll like leave in the averages. Okay, so you can compare yourself to the average. All right. Now, I don't put lab scores on Canvas grades every week because of the way I grade them. Okay, so what I do, whoever gets the best score at the end of the semester, maybe it's 75%, 80% of the total available points, that person gets the full grade, which is 150. Okay, and then I grade everybody against that 150. So at the end, labs actually usually help. As long as you keep handing them in, you're fine. Labs will always help. Okay, so end of semester, you'll get a score out of 150, usually between 120 and 150 if you hand them in. Okay, unfortunately that means because I have to wait to know the best total, I can't give you a grade along the way. So you've got to wait to the end, but trust me, it's worth it because it gives you more points if you're grading against the best score, not some theoretical total. Okay, if that doesn't make sense, drop a line in the discussion or the water cooler and we can talk about it more. Okay, so today, the plan, what I'm going to do, I'm going to give you my regular, face-to-face, say we're doing this lab on college campus, I'll give you my pre-lab, right? It's actually pretty straightforward. I just basically go over a few terms and remind you of what solubility curves are. I'll do that in a moment, okay? Then when we talked about that, we'll talk about the assignment overview, what you've actually got to do that's different, okay? So it's really simple, actually. You just submit all your work through Pivot, essentially, which we'll talk about in a moment. Okay, so to it then. So if I just go here are my... this is actually the assignment, if you're actually, maybe we're taking one or two, maybe you've seen this, okay. This is your actual physical in-lab assignment. And I just basically go off the introduction from this and just talk about it in my pre-lab, okay, because it's usually pretty straightforward, okay. So what I'm going to do first is talk about the solubility curve, okay. You've seen this already, okay, it was in the note packet. Okay, that's not great, is it? It's kind of too big for the, we just do it down there. We'll move it up and down a little bit. Okay, so what a solubility curve is a temperature versus solubility in grams of solute, for example, potassium chloride, right, per 100 grams of water, the solvent, right? That's how we measure it, yeah? And as you can see, the solubility for most ionic materials increases with temperature. And we talked about that in the packet. You know, essentially, when you get to a higher temperature for water, you weaken its bond, so it essentially sticks to the solvent. Sorry, solute. Solvent bonds weaken, so they stick to solute ions easier. Okay, so things will dissolve to a greater extent, more grams per 100 grams at higher temperatures. Okay, now they use grams incidentally because grams don't change with temperature, where volume, you know, expands and contracts with temperature, so it actually stays the same. That 100 grams of solvent stays the same as long as none evaporates. Okay, so as we mentioned, most times we see an increase in solubility with temperature, but occasionally we'll see a decrease. Ammonia is actually a gas, not an ionic compound. Okay, and this probably has, like I mentioned in the notes, waters of hydration. Okay, so there's a few oddballs. They're usually special cases. Okay, now remember how we kind of talked about this graph? That line, so if I pick, you know, potassium chlorate here, this one, that line is the maximum solubility. If I pick a nice number, 50 degrees C, 20 grams per 100 grams of solvent, right? So at 50 degrees C, it dissolves 20, right? If I go up to pick a number there, 80 degrees C, it dissolves 40. Okay, so we see how it goes up. And it's not a linear relationship, often it's exponential in nature, which is interesting. Okay, so that line represents the maximum concentration allowed at that temperature. Anything under the line will be a lower concentration, would also be allowed at that temperature. So, you know, I can have just water at 80 degrees C and just keep adding the salt until I get to the maximum allowed at that temperature. Okay, and when we have the maximum in there, that's called saturation. So these are lines of saturated solutions. Okay, the maximum concentration you could ever get. Okay, and that's a fixed number. So at a fixed temperature, every material has a fixed maximum concentration it can be. That's called saturated solution. So when you see the phrase saturated solution, you can't get any more in there. Okay, now that's the graph. I'm going to put that to one side right now. Okay, and I'm going to talk about the vocabulary words. Okay, so we talked about these before already. We don't actually need this stuff down here. I'll just put that over there. Okay, so we don't need that either, you know that. Okay, so let's remind ourselves. What's a solute? Well, a solute dissolves in a solvent to make a solution. So we know that from before, right? So hopefully that's good. So, for example, sodium chloride dissolves in water to make seawater. Sugar dissolves in water to make Pepsi, essentially. Okay. Solubility, that's the measure of how much stuff is dissolved. Okay, that was a graph of solubility. Okay, so let's go back to that real quick. That was a graph of solubility. Anything under the curve is an available solubility value. The line represents the maximum solubility. Okay. Saturated, we talked about. Okay, saturated is on the line. You've reached the maximum possible allowed concentration at that temperature. Okay, so different materials have different saturations at different temperatures as governed by the line on the graph. Unsaturated, that's just the stuff under the line, right? So any concentration from 0 up to saturation is said to be unsaturated. Just think of it, it's not quite at its maximum, and it can be anything between 0 and maximum to be unsaturated. Now we've got the weird one. Supersaturated. Now be very, very careful with this phrase, okay? It's the last one on the list I'm going to talk about. Let's go back to your graph here. Okay, let's pick an easy one. Let's go back to potassium chlorate here. So imagine I'm making a potassium chlorate solution at 80 degrees C, right? How much can I dissolve in there? 40 grams, right? I can dissolve 40 grams of potassium chlorate at 80 degrees C in 100 grams of water. Fair enough, yeah. So let's pretend I make a saturated solution. Fantastic, right? Then, let's say once I've made my saturated solution at 80 degrees C, I take it away and just put it in a cooler area, right? What's going to happen? Well, that concentration, well, that solution, I should say, that solution will cool down because you've just taken it off the heat, right? So And it's literally, here's a weird concept, right? So the solution kind of goes into panic, right? Because what's happening? Well, you've got that stuff all dissolved, so you've got your 40 grams dissolved, right? But now, because it's getting cooler, maybe it gets to 50 or something, the maximum allowed at 50 is half that, right? So it's overloaded, right? So you can, if you cool a solution down slowly from saturation, and the stuff doesn't come out of solution right away, it's temporarily still in there, and that solution is called supersaturated. So supersaturated solutions are made by getting the maximum concentration, saturated solution at high temperature, cooling slowly, and it will remain in solution even though it shouldn't, right? Okay, now that's kind of funny because that's an unstable solution, yeah, and organic chemists love this because they make these solutions all the time. You can literally scratch the glass with a glass rod and bang, you'll get precipitation, which is kind of a nice trick. It's almost like magic, right? Sometimes you look at it funny, or precipitate. Not really, but you get the idea, right? Okay, so be familiar with that term supersaturation and how it actually happens. You prepare a saturated solution at a high temperature, cool it to a lower temperature, and it's temporarily dissolving more than it should. With a little bit of a nudge, you can induce precipitation and it will get down to its correct value, and the rest will come out as a solid precipitation. All right, now that is your lab. Pretty straightforward in terms of the concepts, okay? All right, now last thing, it's actually under here. I did print this from your Pivot site, okay? So what this actually is just instructions how to go to Pivot and do the experiment, and you can literally read through that yourself, right? So, it's one of those where actually you submit the work at Pivot. You don't send it to me this time, okay? I'll write a note in the Canvas description. This semester, most of the labs, you'll actually complete them at Pivot, and then I get on there as a grader and I just grade them on Pivot. So it's actually easier for me, right? But to be honest, one way or the other doesn't matter. But okay, so you can read through, and it talks about literally what I've just been talking about. This can be done, you can either print it or just fill it out online. And then, you actually go to a virtual lab and start adding solutions. It's I took a look at it, it's kind of cool and cheesy at the same time, right? And then, it talks about how you generate graphs, and, and you'll actually store your data in Pivot. I'll go in later and check it and get a grade for you, okay? And again, if you ever want to know your grade, just send me a quick email. But they won't be up on Canvas, okay, until the end of semester. All right. Hopefully that makes sense. Any questions or concerns, discussion or walk or chat. See you guys next time.